Hey guys, Mrs. Flanagan here. Today we are going to talk about solving quadratics. This is a review from what we talked about last semester. When we talk about the difference between factoring and solving, notice that with factoring, there's no equal sign. With solving, there is an equal sign. When we factor, you first need to identify the GCF, which in this case, the GCF is 1. So there's really none. There's nothing we do with the GCF of 1. It doesn't change our problem. And we identify our A, B, and C. Then we do our number game. The two numbers need to multiply to -5, since that's what A times C is. 1 times -5 is -5. But add to B, which is a 4. And those two numbers are 5 and -1. And we put those two numbers inside of our double axe, Hippo butts, so it's a +5 and a -1. Our A in this case is 1. And so really we have a 1x plus 5, and we have a 1x minus 1. We don't have to write the 1x, and so it's really just x plus 5 and x minus 1. And the factors then are two sets of parentheses in this case. And now when we talk about solving, we're setting them equal to 0. You set each factor equal to 0. So you take the x plus 5 and the x minus 1, and you set it equal to 0, which means this factor, the x plus 5, needs to be equal to 0. And this factor, the x minus 1, needs to be set equal to 0. And now we solve for x. Undo the add 5 by subtracting 5. So x is equal to -5. And solve for x by undoing that subtract 1 by adding 1 to both sides. So x is equal to 1. So our two answers are -5 and 1. You could also write it as x equals -5 comma 1. Either way is correct. Notice again, factoring has parentheses and solving are just numbers. Questions that you should ask yourself when solving a quadratic. If the letter is written only one time, then you're going to solve it by square roots. That's when you either get the x squared or the parentheses to the power of 2 all by itself and take the square root of both sides. If their letter is written more than once, then you want to check to see if you can factor. That means the number game works. If the number game does not work, then you're going to use the quadratic formula, which we learned last semester. It's important to recognize that with all these different methods for solving quadratics, the equation that you're given, so the equation that you start off with when solving by square roots, does not have to equal 0. When you're factoring, the equation does have to equal 0. As well as with the quadratic formula, the equation also has to equal 0. So with factoring and quadratic formula, sometimes you have to add or subtract things to one side so that you get the equation set equal to 0. With this first example, the letter is written twice, so it's either going to be factor or quadratic formula. Always check factoring first. So check the GCF, which in this case is a 1, so there's nothing we're going to do with that. Then identify your A, your B, and your C so that we can do our number game. We want two numbers that multiply to 1 times 1, which is 1, but those same two numbers have to add to the -2. And those two numbers are a -1 and a -1. So put them inside of our double axe Hippo butts. And then because our A is a 1, really we just have an x minus 1 and an x minus 1. And it's set equal to 0. Now we take each of our factors and set them equal to 0. So our first factor, x minus 1, needs to equal 0. And then our second factor, also x minus 1, needs to equal 0. And we solve by adding 1 to both sides, which means x is equal to 1. And then we solve by adding 1 to both sides, which means x equals 1. You can also write the answer as x equals 1 comma 1. Either is fine. In Sec 3, they're going to emphasize this more because you're going to learn something called multiplicity. And so in Secondary 3, they're going to want you to write it out twice. But in this class, it's okay to just write it once. For part B, notice that the letter is written only one time. There's no other x. And so we're going to solve by square roots. We need to get the parentheses to the power of 2 all by itself, which notice it already is. So then we can go straight into square rooting both sides. So square root this left side and square root this right side. What happens then between this power of 2 and the square root is they undo each other. So the 2 and the square root go away, which leaves you with just the x minus 3 equals the square root of 9. You can type in the square root of 9 in your calculator, or if you have that memorized, either works, but the square root of 9 is 3. Remember that when we're solving and we're taking the square root, there's always a positive and a negative. So it equals both a positive 3 and a negative 3, which means we really have two equations. We have this x minus 3 equaling a positive 3, but also we have this x minus 3 equaling a negative 3. With solving then, we add 3 to both sides, and that gives us x equals 6. And then we also add 3 to both sides for this orange equation, and that gives us x equals 0. So you can keep the two answers separated like this, or you can write it as 0, 6. Notice that with part C, the equation is not equal to 0. So we need to get the equation set equal to 0. In order to do that, we subtract 15 from both sides. Notice that the negative 7x and then minus 15 cannot be combined. These are different terms. They are not like terms. So you have to keep them separate, which means really the equation that we're solving is 2x squared minus 7x minus 15 is equal to 0. Now that it's equal to 0, let's try factoring. The letter's written twice, so we can't do square roots. We have to go next to factoring. Check the GCF. The GCF between 2, negative 7, and negative 15 is a 1, so there's really nothing that we do. Go straight into identifying your A is 2, B is negative 7, C is negative 15. And we need to find two numbers that multiply to 2 times negative 15, that's negative 30, but add to our B, which is a negative 7. And those two numbers are 10 and it'd be a negative 10 and a positive 3. And we put those two numbers inside of our double axe hippo butts, and that's a negative 10 and a positive 3. Our A in this case is a 2, and so this becomes 2x minus 10 and 2x plus 3. Don't forget to simplify if you can. Simplify. So between a 2 and a 10, you can divide by 2. And so that gives us x minus 5. And then between 2 and 3, there's nothing you can divide those by, so it just stays as 2x plus 3. Now comes the set equal to 0 part. Equals 0, which means you need to take the factor of x minus 5 and set it equal to 0. And then you need to take the factor of 2x plus 3 and set that equal to 0. And now to solve this equation, we add 5 to both sides, and that gives us x equals 5. And then to solve the purple equation, we subtract 3 from both sides, and that gives us 2x equals -3. We're not done because that 2x, x has to be by itself. We need to divide both sides by 2. And so x is equal to -3/2. And for part D, notice that the letter is written only one time, so we can solve by square roots. We need to get the x squared all by itself. Right now, the x squared is being multiplied by a -5. We undo multiplying by dividing both sides by a -5. And now we have x squared is equal to 25 divided by -5 is -5. And since the x squared is now by itself, we can go into square rooting both sides. The power of 2 and the square root undo each other, leaving us with x equals. Remember that the negative underneath the square root is an I. And then the 5, you can put the square root of 5 in your calculator, and it will give you square root of 5. So it doesn't simplify. But the way we write this is we put the I in front of our square root of 5. And because we're solving by square roots, there's always a positive and a negative. And so your answer is I root 5 and negative I root 5. Let's skip example E for now and go to example F. Notice that the equation needs to be set equal to 0. So in order to do that, I'm going to subtract 5x from both sides, but I'm also going to subtract 4. And so what that leaves me with is x squared minus 5x minus 4 is equal to the 5x minus 5x undo each other, become 0. 4 negative 4 becomes 0, so the whole thing is 0. Now, because the letter's written twice, we can't solve by square roots, so go straight into factoring. Check your GCF. The GCF in this case is 1, so there's nothing we do about it. Our A is 1, our B is -5, and our C is -4. We want two numbers that multiply to -4, but add to -5. And those two numbers, there is no number that multiplies to -4 and adds to the -5. So that doesn't work, which means we want to do the quadratic formula. X is equal to the opposite of B plus or minus the square root of B squared minus 4 times by A times by C all over 2 times by A. You want to take the part underneath the square root and type that into your calculator. So -5 squared minus 4 times 1 times -4 in the calculator is equal to 41. And then we have a -5 is a +5 plus or minus the square root of 41 all over 2 times 1, which is 2. Check to see if you can simplify the square root. So put that into your calculator. And it doesn't simplify, so we keep it as the square root of 41, which means the two answers are a 5 plus square root 41 over 2 and 5 minus square root 41 over 2. All right, the next one we're going to do, skip G, skip H for now, and come to J. All right, the letters only are in one time, and so we want to solve by square roots. In order to solve by square roots, the parentheses to the power of 2 has to be all by itself. Right now it's being added by 6, so it's not by itself. You have to undo that adding of a 6. We undo adding by subtract, so we have to subtract both sides by 6. And now that leaves us with the x minus 2 squared. Those undo each other, so they're gone, is equal to negative 10 minus 6 is negative 16. And the parentheses to the power of 2 is by itself, so now we can square root both sides. The power of 2 and the square root undo each other, leaving us with x minus 2 is equal to, remember that the negative underneath the square root means we have an I. And then the 16, the square root of 16 becomes 4. And so this becomes 4i. Because we're square rooting, we have two answers, a positive 4i and a negative 4i. And that gives us two different equations. The x minus 2 is equal to a positive 4i, but also the x minus 2 is equal to a negative 4i. When solving this green equation, add 2 to both sides. That gives us x equals, these are not like terms. You cannot combine them. You have to keep them separate. And so it becomes 2 plus 4i. And solving the orange equation, we add 2 to both sides. And that gives us x equals 2 minus 4i. What I want you to do now is to try example E, G, H, and J. So E, G, H, and J on your own. Then come back to check your answers. Go ahead and pause the video now. For example, E, it's important to show that you checked the factoring and that it doesn't work, and so then you went into the quadratic formula. The next important part is to recognize that these three pieces can all be divided by 2. When you divide all of these by 2, this is what you end up getting. You don't have to write the fraction line and the 1 on the denominator, and so you can leave your two answers like this. For part G, this one does work for factoring. The number game does work. And we end up with 1/5 and 1. For part H, you can solve by square roots because the letters are written only one time, and you end up with 3 and negative 3. And then for part J, again, it's important that you show you checked factoring and it doesn't work, and so you need to do the quadratic formula. Again, with this piece, the square root of a negative 4 becomes 2i, and then these parts, there's 3 different parts right here, they can all be divided by 2. When you do negative 2 divided by 2, it's negative 1. 2i divided by 2 is just 1i, and 2 divided by 2 is 1. And we don't have to write the fraction line with the 1 on the denominator, and so those end up being your two answers.